Okay, so let's start our today's physics session from here. I think we solved this question. Did we solve this question or no?
Sir, I think we didn't solve these questions.
Okay, so let's start from this question and let's continue and answer for this question. Here we have two people and they are trying to open the door. Okay, for example, the first person, this person, let me to find my marker here. See that this person is B and this one is A. This person, for example, one of them is trying to open the door and the next one is trying to close the door, and they are applying the same force and in the balance situation, and no one can open the door and no one can close the door. The door will remain in the same situation. So based on the question we have like this. Let me open one new slide. I want to make this question very simple for you. Okay, for example, here we have this condition. And this is the fixed point that the door is fixed here. Fixed point or pivot that we call it. And the first person is applying in this direction. For example, if we consider the force which is applied by the first person, person A, will be in this direction. This direction. And the second person will apply in the opposite direction. And how much is the distance of this person? And how much is the distance of this person from the pivot? Okay, now let's see that. For example, the distance of the first person is 20 centimeter and the next one is 80 centimeter. Okay, this is 20 and this is 80. Okay, if we accept the force of the first person as F1, let's see how much is F1. F1 is 200 newtons. 200 newtons. 200 newtons. Okay, so F1 is question. We should find F1. Actually, when I defined the moment for you, moment or F is equal to moment, if we accept moment as M, yeah, M or moment was equal to F multiplied by distance. Okay, so I told you that this force may affect how? Perpendicular. Okay, perpendicular multiplied by the shortest distance. Okay, so here if you want to find the moment of this, the first one, for example, if you say that M1 or the first moment is equal to F1 multiplied by D1, so moment of the first one will be equal to how much force do we have? We have 200 newtons. 200 newtons multiplied by how much is the distance? Distance is 20 centimeter for the first force, 20 centimeter. Okay, so how much is the moment? Moment is equal to 200 multiplied by 20, so it will be 4000 Newton centimeter. But now see that this is as a single effect. But here we have what? In here we have one system. Here we have one system. In one system, this the formula will be completely different. In a system, so the first, the moment of what? Moment of clockwise is equal to moment of anticlockwise. Okay, I hope that you understand the point that I have written here. If you can understand this point, so you may continue explain please this one. I have written that in a system that we have two moments, or we might have more than two moments. Okay, so in a system, moment of the clockwise must be equal to the moment of anti-clockwise. So what does it mean? If you can explain, so you may open your mic and continue. If you cannot, so let me explain it myself. Okay.
Sir, in Persian we say مخالف أقرب به ساعت و همجهت أقرب به ساعت. Is it true?
Yes, that is exactly. So the total moment of clockwise, that it makes the object to move the same as the clock rotation, is equal to the moment of the anti-clockwise, which is moving, making the object to move against the clockwise. Okay, so that's exactly the thing. Now let's come to here. In this example, we should explain this situation. For example, the first here, if one make the object to move clockwise or anti-clockwise, who can say this one? If one, yeah, continue, please.
I think it's clockwise because it's positive.
Is it the clockwise or anti-clockwise? Let me draw an o'clock here for you. Okay, so this is your o'clock. Yeah, this is 12. And this is 1, 2, 3, 4, 5. Sorry, 5 is instead of 6. Let me write here. 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the clock is moving this direction or this direction, opposite this one. So now see that the clock is moving this direction. So this direction, it means that the first F1 make the object to move anti-clockwise, means the opposite of the clock. Okay, but F2 causes the object to move the clockwise. And if you find the moment of F2, and if you find the moment of F1, and if we make them in equal situation, then the moment will be found like this one. Okay, so here let me draw again this graph for you, then let's answer the question. For example, this is the door, and this is the fixed point of the door, P1. Okay, so the first F1, which is 200 newtons, making the object to move against the clockwise. Yes, against the clockwise. And what about F2, which is not clear, and the distance of this one is 20 centimeter, and the distance of this one is 80 centimeter. Okay, so how to find this one? I told you that in a system that we call them that the moment of clockwise is equal to the moment of anti-clockwise. If we say that M1, for example, the anti-clockwise is equal to the moment of M2 clockwise. So instead of f1 m1 we can write f1 multiplied by d1 equal to, instead of m2 we can write f2 multiplied by d2. Okay, so here f1 is 200 newtons, and next one d1 is how much? 20 centimeter. And how much is d2? d2 is 80 centimeter, and only f2 is unknown. So let's find f2 here. Okay, based on the physics, if we have one unknown in one equation, we should divide by the factor of the unknown. For example, we should divide two sides of our equation by d2. Okay, now this d2 will be removed with this d2. We have only f2. So this f2 will be equal to f1 multiplied by d1 over d2. Okay, so let's just put their numbers. Okay, here we have f1 is 200 newtons multiplied by d1 is 20 centimeter. Okay, over d2 is 80 centimeter. Okay, now f2 will be equal to, okay, so remove this 1 centimeter will be removed with this centimeter. We have 0 will be removed with the 0. We have 2 over 2 is 1, 8 over 2 is 4. Okay, now you may divide 200 over 4, so the result will be 50 newtons. Okay, so what does it mean in this situation or in this condition? Let me bring the real picture here. Okay, now see that how interesting is this picture. The first person, this person A, should use 200 newtons force with the 20 centimeter distance to be equal to with this person, that this person is applying just with 50 newtons force with how much distance? With 80 centimeter. Now see that moment is equal to what? Force multiplied by distance. So as we increase the distance, the amount of force will be decreased. This is the case, okay? So how much is the force? The force will be 50 newtons. The second person may apply only 50 newtons force to be equal to 200 newton force of the first person. Okay, I want to draw one example here. You may do check that one, okay? So you may do check, and how can we answer these types of question? Do check and find the answer, then we will move on to the second part. For example, we have one example like this one. Okay, you may do check this question. For example, we have the force which is applying, which is making the object to move anti-clockwise is 400 newtons, which has the distance of 10 meters from the fixed point. And in the next side, we have the force which is applied to make the object move the clockwise is 100 newtons, and the distance is unknown. The distance is not clear. So you should answer this question, solve this problem, and find the distance that which is d2. Okay, you have 2 minutes time to answer these questions, and let me see that how did you answer this question. Yes, Ms. Zahra Islami, did you find the answer?
Yes, sir. I think D2 is equal to 40 centimeter.
40 centimeter. Okay, so you may find with the same system that we are having here, MK system with meter.
Okay, sir.
Sir, it is 40 meter.
40 meter, yeah. I think yes, Miss Zahra Islami, she has gotten the number with this one, the unit with centimeter. Yeah, the unit will be with meter. Okay, how did you answer, Han? How did you find this question? Miss Ilaha Nauruzi, can you explain?
Yes, sir. We have the specific formula. For example, if F1 and D1 is equal to F2 and D2, and here the D2 is unknown, and we should divide it both sides by F2. Then we can find the D2. D2 is equal F1 and D1 over F2, and then we should multiply the F1 by D1, and then divide it by F2, and then we can find the D2, sir.
Okay, yeah, thank you. It's correct. Okay, so you may just identify the amount that you are having. F1 is equal to 400 newtons. D1 is 10 meter. And then we have F2 is 100 newtons. And we have D2 is unknown. Okay, so F2 D2 is equal to F1 D1. So D2 is unknown. We should divide over F2 two sides of our equation. So then we will have D2 is equal to okay, F1 is 400 newtons. 400 newtons multiplied by D1 is 10 meter. Then F2 is 100 newtons. Okay, newton will be removed with newton, and we have 20 will be removed with 2 zeros. Then we have 4 multiplied by 10 will be equal to 40. So D2 is equal to 40 meters. So if we want to make a balanced situation for this example, we should make the distance from the fixed point till the point that the force will be applied must be equal to 40 meters. Okay, so in this situation we should make like this, an imbalanced situation. Okay, the question that we solved, that it is completely solved in this situation, the door which we applied. Okay, you may do check, and here is completely answered. Next one, the formula that I gave you, this is exactly explained here. Okay, so here we have total clockwise moments is equal to total anti-clockwise moment. So you may keep this point always in your mind. Okay, so this is clockwise is equal to the moment anti-clockwise. Okay, so if you want to make one formula for this one, we can write, for example, M1 is equal to M2, or we can say, for example, F1 multiplied by D1 is equal to F2 multiplied by D2. I think in some physics that when I was teaching in Persian, we might have more than one moment. Okay, so for example, if we have more than 1, 2, 3 moments, so we can count and calculate, add all of them in one side, and the next side will be added the same. Okay, so the formula is the same. and a little bit the structure will be difficult. Okay, so come to here. For example, we always think in this situation, we think in the balanced situation, but what will happen if we do not have a balanced situation? Okay, so here you may check this one. For example, from this three condition or three situations, we have which one is making the object. For example, this is condition 1 and this is condition 2 and this is condition 3. From these three conditions, which one of these three conditions will be moved clockwise, will be moved anti-clockwise, or will not move, will remain in the constant or fixed situation? Okay, so let's do check. For example, here in the first point, here we have the force is 200 newtons. Okay, 200 newtons. If you want to find m1 is 200 newtons multiplied by how much is the distance? The distance is 1.5. Okay, how much will be the result? For example, we have 300 newton meter. Okay, let's find the second option. Okay, m2. We have how much is the force? 300 newtons. 300 newtons multiplied by how much is the distance? We have 1.5. Okay, so how much will be 1.5 if we multiply 300 by 1.5? It will be equal to 450 Newton meter. Okay, so the object will move in which direction, clockwise or anti-clockwise? For example, the moment of m1, if we think this one as m1 and if we think this one as m2. Okay, so we found the moment of both of these 2 points. In which direction the object will move, clockwise or anti-clockwise? You may do check and explain your idea.
Sir, I'm not sure, but I think it's clockwise.
It is clockwise. Now see that if we find the difference between the m1 and m2, how much will be the difference? Okay, so let me create one more slide and explain this condition here. For example, if one was m1 was 300 Newton meter, and m2 is equal to 450 Newton meter. Okay, so if we find the difference between these two, m2 minus m1 will be equal to 450 minus 300. So 150 Newton meter, the object will move with which direction? Yes, the clockwise, means it from the right side, clockwise. Okay, and in the middle of, for example, condition 2, if we think here, so if we apply, for example, 200 Newton multiplied by 1.5, we will have 300 Newtons here, and the same 300 will be multiplied by 1 meter, so it will be 300 Newtons. So 300 Newton meter will be equal to 300 Newton meters. So the object will be what? In perfect balance. The object will not move with any side. Okay, now come to in the third point. In the third point, if we apply the same moment, for example, we have 200 Newton in the right side multiplied by how much is the distance? Again, we have 1.5. So here we will have 300 Newton meter. And in the second point, we have, for example, 300 Newtons multiplied by 0.5. If we multiply by 0.5, there the result will be 100 50 Newton meter. So now see that the left side is much more than what the right side. So the object will move anti-clockwise because the moment of the left side is more than the moment of the right side. Okay, so how can we use the moment practically in our daily life? Okay, so here now see that this is what is the name of this one? This is a tower crane. The name of this object is tower crane. You might have seen this one mostly in for example the buildings, the people or the companies that they are making building, and they are using this tool to make the building and to lift the things higher position. Okay, so how can they for example make a balanced situation? So here this is called, for example, if we call them F1, they put a very heavy box here, heavy weight in this position. And what is the distance from the fixed point? If we take the distance, for example, D1, and they usually put the force that the load that they want to lift it from lower position to the higher position. So if we put the name of F2 here, so then the distance will be D2. Okay, so they are using the same for example moment M1 will be equal to M2, or F1 multiplied by D1 equal to F2 multiplied by D2. So this is the formula that the crane towers are using this condition to count how much force. For example, they know how much force is here, and they usually put the same force in the another side to lift it in the higher position. Okay, next one we usually use in this system. For example, here we have range, yeah, and in this range, how can we find? And we usually use the rule of moment rule, and how to, for example, most of the time we need to apply more force, and most of the time we need to apply, for example, less force. And if we have, this is my question, you may check that this question. Okay, so we should have more distance or less distance to easily open the nut. Okay, so you may think this question with the same force. For example, if we apply the same force F equal to 200 newtons, with the same force we should have more distance to open the nut easily, or we should have less distance to open the nut easily. You may do check and answer this question.
Sir, I think we should have more distance.
Yes. Now see that most of the time, if we want to open easily one object or one nut easily, for the range we should have more distance. Why more distance? Because the distance is having the direct proportion with the with that one with the moment. Okay, so let's do check, and I want to work 2 examples for this one, and you should check that, yeah, how effective is the distance that we are having with this one. For example, if we have one range with this much distance, yeah, for example, if we have like this, and we should apply the force, for example, with the F, which is equal to 400 newtons, 400 newtons, to open, for example, this nut. And how much is the distance? The distance is equal to, for example, the distance is equal to, for example, 20 centimeter. 20. Now let me find the moment. Moment is equal to F multiplied by D. Moment is equal to F is 400 newtons. 400 newtons multiplied by, how much is the distance? Distance is 20 centimeter. Now if we count 400 multiplied by 20 will be equal to 8,000 Newton centimeter. Okay, so this is the moment. Now let's do check. For example, if we have a range with this much distance, for example, this is the distance, and the force will be applied here with the same force, 400 newtons, and then the distance will be, for example, 80 centimeter. So we will have here more distance. We will have more distance here. Okay, so let's do find the moment here again. Moment is equal to F multiplied by D, and here we have moment. The force is equal to 400 newtons multiplied by D. D is equal to 80 centimeter. Okay, now you may count. So here you had 8,000. Right now you will have 32,000 Newton meter. So the moment in which part is the moment more? So here we have, of course, in the second option we have more moment. In the first option we have less moment. So moment means that the effect of making object to move. Okay, making object to orbit or move around this one specific point. So in which point we have more force, more moment? In the second option. So that's why if we have more distance we will have more moment, and if you have short distance you will have less moment. Okay, so that's why in the range, and if you are using this tool, as much as the length of the this tool will be long, so the force, the moment will be also the same. And here most of the time when we answer the questions we should have the same unit. For example, here we have Newton, we have centimeter, but try to change the unit in the same one. But here the question is right. Why? Because we have Newton, meter, both are in MKS system, in the same system. So try to do answer for this one and change the units. And next one, here we have we use the moment to open the door, and we use moment to for example find to make this, the things to be balanced. And then this one, the direction is completely very important. For example, we have clockwise or anti-clockwise. So here we have some more questions, and if you are if you have time this one, so you may do check these 4 questions and do answer for these questions. And it's the end of our today's session, and if you are having any question